Well, that was the less enticing parts of knife making right there. Gotta clean all this up around here a little bit. Leaves tend to fall down, make a mess. Well, anyway, this is my anvil. It's a Swedish coleslaw. I think it's a 160. I don't know, I'll have to check on that. Didn't feel like 160 when I lifted it. But anyway, this is it. Made the rack ourselves out of angle iron, and remember when I can remember flowing tons of rod into them joints, and it works pretty good. It holds up very well. Got a couple supports down in there of angle iron welded in, and then I got some joints up here on the top that I welded in. Me and my dad did anyway. And got the forge here. This is the original heat treater source. It was a chimenea. I used to heat treat stock removal blades in charcoal. My first two knives were done here, and I think, stop saying so many times. I think that my dad wanted a chimenea, so we bought the chimenea, brought a bunch of bricks home in the back of the truck, and we had all those bricks in the truck. The back of my truck was just weighed down, and I commented to him saying, knife making is hard work. Anyway, that was this here is the forge, and it's the current heat treat source that I have now. I just set it next to the chimenea, come out back here with the anvil, and pound the iron when I have to do forging. Well, anyways, I'm going to try to get some good forging footage up tonight. I have 2 Damascus billets that I did back in 06. I'm going to run those, try to draw those out. I have a folder, actually a frame lock folder plan for one of them. I'm going to try to execute those plans and make a frame lock folder with a Damascus blade that I forge welded, but that'll be for a later video. I'm just going to do a little forging tonight. So here's the 2 billets I did. Don't laugh at my welds. Just there to hold it on. Did a wire. I got a little Lincoln wire welder. Just weld it onto some round stock. That way I don't have to clamp them every time, because I'm just drawing it out. I'm just, elongating it, making it thinner, thicker, so I can surface grind it and prep it for something that's usable. I might come out a second time, do an actual shape forging, where I hot cut the edges off and do the shaping part, all that good stuff. That's a different video altogether. Bring out 2 fire bricks, the rest is steel on. Bring out actually it's a wood splitter. I use it as a hot cutter, so I can cut those off from the round stock. Get my tongs right there already set up well, sliding out anyway. They're set up. I'm gonna start the forge up, and I just crank up the valve here. And I'll show you something on these forges. It's kind of funny. You kind of create the environment beforehand. You just sort of crack the valve, let some propane fill up the chamber there, and I'm going to stage it, float it this way, back that way. I don't have to move the tank over, but I just want to do it just to makes me feel good. And just kind of put a little propane in the chamber there, walk away for about 5 minutes, and then you start it. And this piezo igniter, when you get one of these things, okay, you're going to wonder why I use a barbecue lighter, or I should say I wonder why I use a barbecue lighter and burn half my hair off. You're not supposed to do that. Piezo igniter, you set it up, make sure that it's not touching any part of the little hole right there. You've made a shim, go down in there, kind of like a washer, just kind of perch it up, and it'll create a void around that igniter. For some reason or not, when it's touching that manifold, it just doesn't light. Don't know why, but that's that. Anyway, crack the valve, let a little propane flow in, and then when I ignite it, I'll just kind of crack the valve quarter way, fire the igniter, and then open it up. Let the heat creep up a little bit to where it's supposed to be. Painted that a couple of years ago using the Krylon camo paint because the face kept rusting. Look at that, it actually holds up against the heat. it's like 1200 degrees right there. stud popped off. Didn't realize I don't have my camera on, but started to pound the corners of the work, trying to flatten it out a little bit. What happened here was that it cooled off, goes out, get back down to heat treat temperature. And have this, the old saying, strike while the iron's hot. Well, that means, there's less work to do when your iron's or your metal is more of a plastic state. That's where the old adage comes from. So now I'm using my tongs. I'm going to be popping it out with my tongs now. Time you move that metal when it's hot like that, you get a lot of material loss. And I'll show you my first attempt at making Damascus when we cool all this off a bit. I'm going to normalize the steel. I'm going to hot cut that ugly section of weld off the back and leave it out here to cool. And I'm going to heat it back up. I think it's like 800 or 900 degrees. Just guesstimation. You just got to kind of feather it in and out of the forge a few times. When you start surface grinding, you can tell whether or not you got it normalized or not. Plus, also normalization kind of realigns all your molecules so it's back to normal. You don't have this weird contorted grain movement in the steel where you got like one end is this element, the other end is this. Kind of just knocks everything back into place. Kind of like when you remagnetize a magnet, or you demagnetize something and it goes back to being magnetic. Pushing out lengthwise now. Then I'm going to go ahead and start hammering those corners diagonally, see if I can push everything back in, make it more of like an ingot. Not less of an ingot, but more of a bar stock. There's a reason why people go out and buy this stuff rather than go out and make it in their backyard. Another thing too is that you flux it using anhydrous borax. Okay? When that borax heats up to forging temperature, it actually becomes an acid and it starts to eat your fire brick up. And I have to go in every time I do that. It's a good idea that if you want to do any heat treating, I have to re-brick that forge. see the corners. I don't know if you can see the corners because it's kind of shown up on the camera, but that foam stuff actually has little pits in it. That was where the borax actually ate apart part of that foam after the last forge welding session I had a few years ago. Actually, I think it was about 2008 that I did that. And the other thing about it too is that if you ever melt brass, nickel, silver, or any of those types of metals, copper, there's something about doing that won't allow your forge to reach forge welding temperature again. So the brick layer at the bottom there, you got to go back in, pull that brick layer out, and re-brick it again in order for your forge to reach that welding temperature again. Just a couple things you ought to know. So if you ever try to like make makumi, and you try to forge weld, you could have problems. I don't know if it's always like that, but other makers have experienced the same phenomenon. Again, see if I can get that stuff to start coming out lengthwise. Going to wind up calling it a day and just a few more swipes because there are a lot of hammer marks in there, so I'm trying to flatten it out. I'm trying to surface grind it down. Might just actually go ahead and cut a corner off. That way it's kind of more or less already prepped for blade shape. We'll see what happens. That's not the way you're supposed to hot cut steel. The corner up here, people say this is seldomly used. Actually, I beg to differ. It's called a hardy hole. And this is where you put your tongs. Your tongs are supposed to fit right in there. And your hardy hole, you make these things called hardy tools. You usually forge them from a square stock. You got tools for rounding, tools for hot cutting. You put your hardy tool in that square right there, put your work on it, smash it against the hot cutter, and it'll chop it off. It'll fall on the ground and you retrieve it. Well, I'm using a wood splitter right here.